Good morning, everyone. Our today's topic include Linux kernel and shell. Today, we will study Linux kernel and shell, which are two very important parts of Linux operating system. Linux is one of the most widely used operating system in the world. It is used in servers, supercomputers, smartphones, embedded system, and even cloud computing platforms. Linux is known for being open source, reliable, secure, and highly customizable. Because of its features, many companies and organizations prefer Linux for their system. In this lecture, we will understand two important components, Linux kernel and Linux shell. Linux kernel, the core part of the operating system that manages the hardware resources. Linux shell, it is the interface through which user interact with the system and run the command. The kernel works in the background and controls hardware operations, while the shell allows user to communicate with the operating system. It is an open source operating system that was developed by Linus Torvalds in the year 1991. Understanding these two components will help us to understand how Linux actually works internally. Now, before knowing that how it works internally, let us see what actually Linux kernel is. Linux is an open source operating system, which means its source code is freely available for anyone to study, modify, and distribute. Linux was created in the year 1991 by Linus Torvalds, a Finnish computer scientist student. Initially, it was developed as a small personal project, but over the time, it grew into one of the most powerful operate, uh, operating systems in the world. Linux is based on the Unix operating system design. Unix was developed earlier and introduced many important concepts such as multitasking, multi-user support, and hierarchical file system. Today, Linux is used in many different environments such as servers, desktop, embedded system, mobile devices. In servers, more servers run on Linux. In desktop computers, Linux distribution like Ubuntu and Fedora. And in embedded system, smart TVs, routers, and IoT devices. And in mobile devices, it is used as Android. And Android is basically based on Linux kernel. One of the major reasons Linux became so popular is that of its stability and security. Systems running Linux can operate continuously for long periods without crashing. It acts as a bridge between hardware and software and manages the system resources very efficiently. Linux kernel is the core or central component of Linux operating system. It acts as a bridge between the computer hardware and the software application. Applications cannot directly communicate with the hardware devices such as CPU, memory, or disk. Instead, they send requests to the kernel and the kernel performs the necessary operations. For example, if a program wants to read data from a hard disk, it cannot directly access the disk. It sends a request to the kernel and the kernel communicates with the disk hardware to retrieve the data. The kernel is responsible for managing important system resources such as CPU usage, memory allocation, device communication, file system operations. Because the kernel controls all hardware resources, it is considered the most important part of the operating system. And without the kernel, operating system cannot function. Now, as we know that what actually Linux kernel is, now moving forward with the Linux kernel components. The Linux kernel is made up of several components that work together to manage system resources. The first component includes process management, after that memory management, then file system management, device drives, system call interface. The first component, that is the process management. In process management, the process is responsible for creating, scheduling, and terminating processes. A process is simply a program that is currently running. Moving forward to the second component, that is memory management. This component manages the system's memory and ensures that each process receives enough memory to execute properly. The third component is the file system. Linux supports multiple file systems and organize data in directories and files. The fourth component is device drives. Device drives are special programs that allow the operating system to communicate with the hardware devices such as printers, keyboards, and hard drives. The final component is the system call interface. This interface allows applications to communicate with the kernel and request system services. Now moving forward with the first point, that is process management. The process management is one of the most important responsibilities of Linux kernel. A process is a program that is currently executing. When we open applications like browser, text editor, or music player, each application runs as a separate process. The Linux kernel performs several tasks related to the processes. First, it creates processes when a program starts. Second, it terminates processes when a program finishes the execution. After that, it performs CPU scheduling. CPU scheduling determines which process gets access to the CPU at the given time. Linux also supports multitasking, which means multiple processes can run simultaneously. For example, we can listen music, browse the internet, write a document all at the same time. Linux also supports inter-process communication, which allows processes to communicate and share data with each other. Now next we have memory management. Memory management is responsible for controlling how the system's memory is used. It includes allocation, deallocation of the memory, virtual memory management, segmentation, cache management, and paging. When a program runs, it needs memory to store data and instructions. The Linux kernel allocates memory to the processes when they start executing and releases memory when they finish. Linux uses virtual memory, which allows the system to use disk space as an extension of RAM. For example, if a computer has 4 GB of RAM but a program needs more memory, the system temporarily stores same data on the disk. Linux also uses paging and segmentation to organize memory efficiently. Another important function is the cache management. Cache management improves system performance by storing frequently used data in the fast memory. Hence, memory management ensures that the processes do not interface with each other's memory space. Now, moving forward with the file system and device management, the Linux kernel manages both file systems and hardware devices. Linux supports multiple files systems such as extension 4, most common in the Linux, FAT and TFS. This allows Linux to read and write data from different types of storage devices. The kernel also manages storage devices such as hard drives, SSDs, and USB drives. Device drivers are used to control hardware devices. For example, printer driver controls printer operation, disk driver controls hard disk operation, network driver controls internet connectivity. The kernel also handles input and output operations, which include reading data from the devices and writing data to the devices. Hence, file system manages and stores devices and handles the operating system input-output operations. Now moving forward with the block diagram of Linux kernel, The diagram consists of basically three layers, that is, user space, system call interface, kernel space, and hardware layer. These all are the different layers by which the components interact with each other. The Linux kernel shows how different components interact with each other, and it basically has three main layers, namely user space. In user space, this is where users' application run. Examples like web browsers, text editors, and other software programs. In system call interface, applications do not directly interact with the kernel. They send requests through the system call. Then system call acts as a communication bridge between user application and the kernel. Kernel space. Kernel space contains important system components such as process management, memory management, file system, device types. Moving forward to the hardware layer, in this layer, it contains physical hardware such as CPU, memory, and storage devices. The kernel communicates with the hardware layer to perform operations. Now let us understand what is shell. The shell is a program that allows user to interact with the operating system. It is also called a command line interpreter. A program that allows user to interact with the operating system is called shell. Instead of using graphical icons and menus, the shell allows users to type command directly. Like if we take examples, user can type commands like create file, delete file, run program, manage processes. The shell acts as an interface between the user and the kernel. When a user enters a command, the shell interprets it and sends the appropriate request to the kernel. The kernel then executes the command and returns the result. This process is done within very milliseconds so that we could not get that what actually is done. But whenever we give a command to the system, it is shell that interprets it and sends the request to the kernel. The kernel then executes that command and processes the result, then returns the result to the shell. That is what how actually we see our result, what we are supposed to do or what a task we are performing. Now moving forward with the popular shell offsprings. Some of the most popular shell offerings include bash burn again shell, shell burn, C shell, corn shell, Z shell. Linux provides several different types of shell. The most common shell is bash, that is burn against shell. Bash is the default shell in many Linux distributions. Another shell that is Burn shell, which is one of the earliest Unix shell. The C shell provides syntax similar to C programming languages. The Cache shell, that is Corn shell, combines features of both Burn shell and C shell. And the advanced shell, that is Z shell, which provides many modern features such as improved command completion and customization. S shell was the most mm, widely used and it is used in the earlier times. After that, when C programming was developed or introduced in the Linux, then C shell was used. After that, combining the features of Burn shell and C shell, Corn shell was created. And after that, with the modern features and improved command with customization, Z shell was designed. Each shell provides similar functionality but may offer different features and scripting capabilities. Now moving forward with the features of Linux shell, some of the features that are listed are command execution, scripting capabilities, input-output redirection, types and filters, job control. The Linux shell provides many powerful features. One of the most important features is command execution. Users can run programs or perform system operations simply by typing commands. Another feature is scripting capability. Users can create shell scripts that automate repetitive tasks. The shell also supports input and output redirection, which allows user to control where the output of a command goes. Now moving forward to the next feature, that is pipes and filters. And the powerful feature is pipes and filters. Pipes allows the output of one command to be used as an input for other command. The shell also provides job control. Job control allows user to manage multiple tasks running in the background. If multiple programs are running in the background, it is the feature of kernel, that is job control, that it will manage all the tasks that are running behind. And pipes will be used as input and output for one command and input for other. If one program is giving an input, it would be used as an output for the other one. Now moving to the shell scripting features. Shell scripting allows user to create small programs that are to automate system tasks. Scripts can include variable and data types, conditional statements, loops like for, while, and function supports. For example, the conditional statement such as if statement that allows a script to make decision. Loops are used like for loop and while loop, as it allows a script to repeat task multiple times. By using function, which allows a script to organize code and into reusable blocks. Shell scripting is widely used by system administrators to automate system maintenance tasks. In automation of maintenance tasks, shell scripting is widely used because we can include scripts like variables, conditional statements, loops, and functions. And as it allows users to create small programs that automate system tasks. Now moving forward to the next slide, that is advantage of Linux shell. Now here are some of the advantages of Linux shell that includes automation of tasks, powerful text processing, remote system management, customizable environment. The Linux shell provides many advantages. One of the major advantage is task automation. Users can write to automatically perform tasks such as backups, software installation, or system updates. Another advantage is powerful text processing. Linux command can easily process large amount of text data. The shell also supports remote system management. System administration can manage remote servers using shell commands. Another advantage is customization. That is, users can modify the shell environment according to their preferences. Now, moving forward, what we have learned through this session. In this lecture, we learned about the Linux kernel and shell. The kernel is responsible for managing system resources such as CPU, memory, and hardware devices. It acts as the core component of operating system. Shell provides user interaction and provides interface that allows user to interact with the system entering the command. Together they powerful Together they form powerful operating system environment. Like the kernel and the shell forms the foundation of Linux operating system. Understanding these components is essential for students who want to learn Linux administration, programming, or system management. Hope you understood Linux kernel and shell. See you soon in the next session. Thank you.